All right, welcome to The Explainer. Today, we are tackling one of the biggest, most mind-bending questions in all of physics. Are particles, the tiny little building blocks we thought made up everything, actually real?
I mean, it's a question we've all asked at some point, right? You learn in school about atoms, and then you drill down to protons, neutrons, and electrons. But what if I told you that's not even close to the whole story? What if the very foundation of reality is something much, much stranger?
So let's just dive right in. You've got two stories here. On one side, the old, familiar story. The universe is made of tiny, solid bits of stuff, kind of like cosmic Legos. But then, on the other side, you have what modern physics actually tells us, that reality's true foundation is made of these invisible, all-pervading quantum fields. Today, we're going to unpack this incredible shift. So let's start with the idea that just feels, well, intuitive, the one we all kind of picture in our heads. The universe as a collection of tiny little dots.
Yeah, this is the classical picture. An electron is a tiny dot. A quark is another tiny dot. You just pile up these fundamental Lego bricks in different ways, and bam, you get everything you see around you. Simple, neat, and as it turns out, just plain wrong.
See, the thing is, when physicists really started pushing the boundaries and running some wild experiments, they found some really serious cracks in this whole universe as dots idea. The model just couldn't explain what they were seeing. So this dot model had some major issues. First up, particle creation and annihilation. I mean, if particles are fundamental, you shouldn't be able to just make them or destroy them. But in particle accelerators, we see particles pop into existence from pure energy and then vanish into a flash of light all the time. The dot model, it has no answer for that. It also completely clashes with Einstein's special relativity, which tells us that matter and energy are basically two sides of the same coin. So to solve these incredibly deep mysteries, physics needed a radical new idea. And that idea, the big reveal, is the concept of fields. So what on earth is a quantum field? Well, think of it as a kind of fundamental substance that exists absolutely everywhere in space and time. And here's the crucial part. There isn't just one. Nope. Every single type of particle we know, electrons, photons, quarks, you name it, has its own unique field that completely fills the entire universe. Just pause and think about that for a second. Right here, right now, where you are, there is an electron field and a photon field for light, and an up quark and down quark fields. All of these invisible fields are layered on top of each other, all coexisting in every single part of the cosmos. It's wild. Okay, so now that we've established that these fields are literally everywhere, we can finally answer our big question. What then is a particle? Get this, a particle isn't a thing at all. It's an event. It's a little localized vibrating bundle of energy in a field, what physicists call an excitation. So when our detectors see an electron, what we're really seeing is a tiny concentrated vibration in the electron field. This, right here, is the key insight. Now, I know this can be a bit hard to picture, so let's use a really great analogy to make it crystal clear. The cosmic ocean. Imagine a huge, vast ocean, and it's perfectly calm. That smooth surface, that represents the field, just sitting there, at rest. Now, imagine you tap the water. You've just added a little bit of energy, and it creates a localized ripple. That ripple, that is the particle. It isn't made of some different water stuff. It's just the water itself, for a moment all excited. This new picture completely torpedoes our old idea of empty space. I mean, if these fields are everywhere, is any part of the universe actually truly empty? The answer is a big, fat no. The vacuum isn't empty, it's just all those fields in their calmest possible state. But calm in the quantum world doesn't mean perfectly still. Oh no, the fields are constantly fizzing with borrowed energy, causing these virtual particles to wink in and out of existence for tiny fractions of a second. And this isn't just some wacky theory. If you place two metal plates super close together in a vacuum, this buzzing actually creates a real, measurable force that pushes them together. It's called the Casimir effect. Empty space is alive. So this idea of quantum field theory isn't some fringe concept cooked up by a few scientists. It is the absolute bedrock of modern physics. It's the true cosmic blueprint. I mean, just look at this. The standard model of particle physics, our most successful theory of how the universe works, period, is built entirely on this idea.
It's a field theory. What we call an electron is just an excitation, a ripple in the electron field. A photon of light, a ripple in the photon field. The famous Higgs boson, you guessed it, an excitation of the Higgs field. This isn't a metaphor. This is literally how physicists understand reality to be structured. So the most important takeaway from all of this is right here. Particles aren't fundamental. They are emergent phenomena. They're like notes being played, but the real instruments, the true foundation of everything, are the quantum fields themselves. And that, of course, leaves us with one last, really profound question to think about. If you, me, the stars, the planets, if everything is just a complex, interacting dance of vibrations in these fundamental fields, well, what does that even mean? We aren't the Lego bricks. We are the patterns they make. We are the music, not the instruments. What does that truly mean for how we see ourselves and our place in this incredible cosmos?